Here's a quadratic equation. X squared is equal to 49. And if we add negative 49 to both sides, we get x squared minus 49 is equal to 0. And of course, x squared minus 49 is a difference of squares, so we can factor and apply the zero product property to determine that there's two solutions. 7 and negative 7 are both solutions to this equation. But there is another way to do it. We could simply take the square root of both sides. Well, the square root of x squared is x, and the square root of 49 is shown here. Remember, there's a positive and a negative square root of all positive numbers. And of course, that means that the square root of 49 is either positive or negative 7. And we can write it this way. The plus or minus symbol indicates that there are two answers. 7 and its opposite, negative 7, are both solutions to this equation. This method comes in handy when the number is not a perfect square. In this case, if we add negative 125 to both sides, we'll get x squared minus 125. But since 125 isn't a perfect square, it's not a difference of squares, and the binomial is not factorable. So we can't use factoring to find the solution to this equation. So we'll go right to it and take the square root of both sides. And in fact, that's considered the exact answer. There is another way to write it, known as simplest radical form, and that's because 125 is equal to 25 times 5, and you can take the square root of the 25, and you get this expression, and it's read positive or negative 5 root 5. And that's simplest radical form for the square root of 125. The other thing you could do is to use your calculator, find the square root of 5, and round off. And I've done so here, choosing to round off to the nearest hundredth. So the exact answer is positive or negative 5 root 5. And the approximate answer to the nearest hundredth is positive or negative 11.18. And we'll look at simplest radical form in much more detail in subsequent lessons. Well, here's another quadratic equation, and because we've already learned how to solve using factoring, we're going to add negative 30 to both sides to set the right side equal to 0. But we examine this and we decide that this particular trinomial is prime. So then we put it back the way it was originally, and we notice that this particular trinomial that's now on the left side is a perfect square trinomial. So we factor it as the product of x plus 3 and another x plus 3. Write it with an exponent as shown, and then take the square root of both sides, and we now see that x plus 3 is equal to positive or negative root 30. So we break that into two separate equations. It means that one of the solutions is that x plus 3 is equal to the positive square root of 30, and the other equation is that x plus 3 could be the negative square root of 30. And then, of course, we add negative 3 to both sides, and one of our solutions is negative 3 plus root 30, and the other solution is negative 3 minus root 30. And in this case, both of the expressions are already in simplest radical form. And to save space, you could consolidate those two solutions by writing negative 3 plus or minus root 30. And if you'd like to get an approximation using your calculator, you would find the square root of 30, round to the appropriate place, and then you have two separate problems. You're going to have negative 3 plus root 30, and then you're going to have negative 3 minus root 30. And we simplify both of those expressions, and we get two approximate solutions rounded to the nearest hundredth, 2.48 or negative 8.48. And here's one. This is also a perfect trinomial square, and there are the factors written with exponents. We take the square root of both sides, and now we're going to add negative 5 to both sides and then divide everything by 4. And it turns out this particular expression is in simplest radical form already, so this is considered the exact solutions to this equation. But if you'd like to round it off, I recommend you type it into your calculator as shown here, putting parentheses around the entire numerator and then dividing by 4 to get the first answer, because we've added the positive square root of 23 to the negative 5 before dividing by 4. And then we have to remember that the other solution is to combine the negative 5 with the negative square root of 23 before dividing by 4. We round to the nearest hundredth, and here's our two solutions rounded to the nearest hundredth. When factoring will not work to solve a quadratic equation, sometimes it is possible to solve a quadratic equation by taking the square root of both sides.